Hello, and thank you for joining today's presentation in the Richardson RFPD webinar series, A Walk Around the Block. My name is Katie, and I will be your Global Spec moderator. Now let me introduce today's presentation. Richardson RFPD is an aeroelectronics company. It is a specialty electronic component distributor focused on the RF and wireless communications, industrial IoT, power conversion and renewable energy markets. With its global reach and extensive technical capability, Richardson RFPD serves its customers through component development and selection, technical support, and world-class logistics and supply chain capabilities. Richardson RFPD had a few simple objectives for its Walk Around the Block webinar series: to organize concise webinars of no more than 20 minutes around an engaging topic, make it applicable to the global engineering community seeking solutions for design challenges, and to feed this community's hunger for information on innovative technologies to help differentiate their own products. In today's session, Stefan Berggren, a senior product marketing manager at u-blox, will explore the drivers for wireless communication in the EV charging market. So without further delay, let me turn it over to Stefan.
Thank you very much for the introduction. On behalf of u-blox, I would like to wish you welcome to this recorded webinar with the title The Landscape of Wireless Technologies, Architectures and Standards in EV Charging Applications. My name is Stefan Berggren and I'm a Product Marketing Manager at u-blox Short Range Radio Product Center. In this webinar, I will first make a brief introduction to the EV charging market and the drivers for wireless communication. I will discuss about suitable technologies and standards that are applicable to use cases involving short-range radio technologies. In the end, I will go into some design consideration when selecting wireless module for your EV charging solution, either for the EV itself or for the charging station. So let us start with the EV charging market. So driven by the reduced environmental impact, low operation and maintenance costs, and last but not least, governmental subsidies, a growing number of consumers and businesses are opting for electrical vehicles, EVs. According to ABI research, there will be roughly 84 million EVs on the streets in 2028, and more than every fifth car will be electric by that time. And given the fast transition towards EVs, there will of course be an increasing demand for EV charging stations at home or at work or in public. ABI research predicts that the 84 million EVs in 2028 will be served by 40 million public EV charging stations. So that is 6 EVs per charging station in average. Other driving factors boosting the market are building regulation, demanding building owners to deploy charging stations, the transition from plug-in hybrids to pure EVs, also increasing the demand for charging stations. And there will be a replacement race that will also come into place later on, and people moving house that also need then to reinstall a new charging pole. So what are the drivers for wireless communication? We can conclude that there is a need for expanding the network of EV charging stations, but also to speeding up the charging, improving the user experience, for instance by making it easier to find free charging stations, simplify billing, and offer a variety of other value-add services. In each of them, wireless connectivity is key. An obvious use case is to provide a nice graphic user interface to the charging station via smartphone or tablet using Bluetooth Low Energy. Furthermore, in order to remotely monitor and control the charging process, the charging station need to be connected to cloud services over the internet. There is an evolution where the EV charging process is getting more and more integrated with the grid. The tighter integration, of course, then the communication need increases. There are several means for ensuring cloud connectivity: Ethernet, cellular, and Wi-Fi, etc. I will later discuss about Wi-Fi for the backend connectivity. Finally, there is a move towards more convenient and hassle-free EV charging, where you're getting rid of the charging cable through either wireless charging or where a robot arm or pantographs connects the charging station and the EV, so-called ACD, automatic connection device. Both AC and wireless EV charging requires a wireless communication channel between the EV and the EV charging station. I will discuss about how Wi-Fi serves this application later in my presentation. So let us discuss about technologies and standards for the EV charging process. So in order to control and monitor the EV charging process, there is an information flow going from the EV and the charging station with data related to identification, charging process status, battery levels, and next trip information, etc. The information is used by different entities in a third-party operated cloud service involving car manufacturer, mobility service provider, charge point operator, and energy suppliers, etc. In the opposite direction, there is a communication flow with aim to control the charging process. Open standard for the above communication flow is essential for ensuring interoperability, where you see some of them in the picture. The communication flow could be divided into backend communication, so that is the communication between the charging pole and the backend service, and the front-end communication, so that's communication between the charging pole and the EV. There are a number of open and proprietary protocols used for the backend communication, including IEC 63110, IEEE 2030.5, eBus, OpenADR, and OCP. The two main alternatives for the front-end communication are SHA-DA-MO and ISO 15118. For smart building charging pole installation, communication flow could go via local energy management system IMS to optimize multiple resource co-located with the EV, so that could be heat pumps or solar energy system, etc. And Wi-Fi can be used for both the back-end communication and the front-end communication, where for the back-end communication it's about really providing a secure IP pipe to the cloud services. A good description and analysis of the different protocol and respective communication is available in the paper Mind the Gap Open Communication Protocol for Vehicle Grid Integration by Mariam Naime and Peter Bach-Andersen. So some words on the ISO 15118 standards. It's an international standards defining a vehicle-to-grid V2G communication interface for bidirectional charging discharging of EVs. The standards covers all 7 layers of the OSI model. The ISO 15118-1 defines overall use cases. The -2 and the second generation -20 version defines the network and protocol requirements. The new release 2020 includes support for wireless power transfer VPT, automatic connection device ACT, bidirectional power transfer BPT for real smart grid support. So that is about managed supply and demand of the power grid, which is becoming increasingly challenging with the rise of renewable power sources. So ultimately, when the EV could store energy when it's produced in excess of the demand and supply it to when it flattens peak in consumption. The ISO 15118-8 defines the physical and the data link requirements for wireless communication, that is for Wi-Fi. Good material and training of the standards can be found on the v2g-clarity.com. So let us discuss about the EV charging use cases. First use case is about the driver that finds a charging station via the infotainment system through wireless communication, cellular communication, and get guidance to drive there. When approaching and within the Wi-Fi range, the communication between the EV and the charging station starts. Over this Wi-Fi channel, there is then a phase including certification, handling, identification, authentication, authorization. Fine positioning is about getting the EV into position, fitting the connectors, or for optimizing the inductive charging process for wireless communication, wireless charging. Then there is a negotiation phase where the charging targets are set and the energy transfer is scheduled. On top of this, you can also define other value-add services. And for the front-end communication, u-blox JodeW2 module fits very well. For the backend communication, besides a user that would like to keep updated on the charging process to get access to historic data, there are several third-party stakeholders such as the car manufacturer, mobility service providers, charge point operators, etc. that need to get access to data generated. So this could be even for monitoring the charging process, to get later information about battery status, to manage billing, to get all sorts of statistics, but also to do predictive maintenance of the charging station and the car. And then it's also about scheduling the charging and manage peak load reduction, load management, and also the integration of renewable energy sources. For the backend communication, u-blox has a broad range of products that could fit very well, where I've mentioned a few of them to the right. Finally, local configuration use cases, you are using a smartphone or a tablet as a graphical user interface to manage configuration of the Wi-Fi access point, to do maintenance, to do firmware updates, and possibly also for payment services. So in this final section, I will elaborate on some of the design considerations you need to make when selecting a wireless module for EV charging. There are two main architectures that you need to consider. u-blox denotes these as host-based respective standalone architectures. If the application runs on a host processor running, for instance, Linux or Android, a host-based module could be used. In this case, the IP stack and the Wi-Fi drivers run on the host CPU, and the Wi-Fi module running the lower communication layers, the physical and MAC layer. The communication between the wireless module and the host goes via SDIO, SPI, USB, or PCI Express for high data throughput. Alternatively, if a simpler MCU is used and when high bandwidth is not a requirement, a standalone module controlled via simple AT command is the best fit. Standalone modules come fully equipped with Wi-Fi or Bluetooth software stack and offer basic communication services out of the box. And that's thanks to u-blox Uconnect Express software. The communication between the MCU and the modules goes over a serial interface, for instance, UART. Another option to consider is whether to use automotive versus professional-grade module. EV charging station could be operating under harsh environment, and an automotive-grade module are qualified strictly according to ISO 16750 AEC Q100. Such modules feature excellent immunity to severe mechanical electrical stress. And they are characterized by lowest possible field rate, failure return, have the long-term product availability to support automotive industry product life cycles, and come with automotive quality processes. The table below tries to summarize what type of module to choose for the charging station and EV implementation for Wi-Fi. Note that I've also separated EV charging station into two columns representing the back-end respectively the front-end communication. So starting with the architecture, for the EV itself we see primarily host-based architecture, where the host is implemented as part of the Linux-based TCU or in the ECU, electronic control unit, running for instance AutoSAR or MicroSAR. For the EV charging station, it's more a mixed bag for back-end communication. We see various implementation for both architectures. Second choice is about Wi-Fi single band versus a dual band. The front-end connection is always dual band as required by ISO 15118-8. For the back-end communication, it's again a mixed bag where some focus on cost and rely on a more simple 11B GNN Wi-Fi module, only supporting the 2.4 GHz band. The third choice is whether to go for a multi-mode module supporting both Bluetooth and Wi-Fi to be able to manage all the use cases I've been talking about. Again, the front-end communication is only defined for Wi-Fi, so no need for multi-mode. However, players that would like to implement both a local interface for configuration as well as a backend connectivity could of course benefit from a multi-mode module. If your charging station also has an LTE connection, it makes also sense to have a Wi-Fi module with an integrated LTE filter to avoid interference with LTE bands close to the Wi-Fi frequencies. Same applies for the EV implementation. If you're implementing charging stations that manage both front-end communication and back-end Wi-Fi communication, you need a module that is able to run simultaneous Wi-Fi access point and station clients. The charging station is connected to an access point, for instance, Wi-Fi router at home, and at the same time act an access point for the EV. Then you also need to consider which Wi-Fi release that should be supported. Again, many players focus on cost and see that the 11B GNN Wi-Fi 4 is meeting their communication need. ISO 15118 also mandates 11N. Wi-Fi 5 offers higher bandwidth on the 5 GHz band through wider channels, higher order modulation, and MIMO. Wi-Fi 6 offers higher data rates, increased capacity, and higher performance in environments with many connected devices. And finally, improved power efficiency, and this is by introduction of DMA and multi-user MIMO. For EV charging, it's primarily the high efficiency that is important when many devices are fighting for the available bandwidth. TCR, a Japanese market research institute with good knowledge in our industry, predicts that the majority of Wi-Fi access points and routers will support 11AX by 2022. But the transition towards from 11B GNN Wi-Fi 4 will not happen really over the night, and when it comes to IoT and EV charging backend communication. However, some look into Wi-Fi 5 for future-proofness reasons. Wi-Fi Alliance do certification of the different releases. However, u-blox is limited the value for actual certification on module level, as you also need to do end product certification. Finally, on qualification, again, the charging station is a mixed bag. Here we see both professional and automotive grade modules selected. EV implementation are always using automotive grade modules. Then there are several other options around security, antenna configuration, Wi-Fi and Bluetooth coexistence, etc. that I don't have time to elaborate into in this webinar. For Bluetooth, there are less options to consider. First of all, Bluetooth is only applicable to the charging station implementation in this case. Also here we see customers seeking a solution for local configuration chooses a standalone Bluetooth module, whereas customer implement a solution with both local configuration and backend connectivity chooses either a standalone or a host-based module. Bluetooth 5 is highly recommended to stay current with the Bluetooth SIG releases. Bluetooth 5 was announced in 2017 and offers higher data throughput, longer range, as well as increased capacity on the broadcasting channels. All features are optional, but it's especially the 2 megabit physical layer that's important for the EV charging, for instance, for firmware updates. The longer range is achieved via new physical barrier-coded PHY with convolutional encoding and error connection. And for this, u-blox has measured around 1.5 distance in line of sight. But it's rather the capacity to offer better coverage when through walls, etc., in indoor environments that really drives the need for this feature. But in this use case, I see limited value for the feature related to EV charging. So, key takeaways. So, in this webinar, we have been talking about the growing market for EV charging solution, how wireless technology play an important role for providing a graphical user interface via a smartphone or a tablet, for ensuring cloud connectivity, complementing cellular and fixed connections, and finally, supporting emerging use cases such as wireless EV charging and ACD. We have elaborated on the selection criteria when selecting the wireless module for the EV charging solution, both for the EV and the charging station. u-blox has a broad portfolio of professional and automotive modules targeting the EV charging market and addressing the use cases architectures, and the Bluetooth and Wi-Fi features discussed during this webinar. For more details about our product, please go to our website u-blox.com. So again, thank you for listening, and with this I hand over to the moderator for some closing remarks. Thank you very much.
Thank you for attending today's webinar in the Richardson RFPD A Walk Around the Block webinar series. Thank you again to Stephen Berggren for today's presentation, and thank you from both u-blox and Richardson RFPD for attending today's session. We look forward to you joining our other sessions in this series. Take care, and we will speak with you soon.